What's up, guys? This is Jahangir from Edporium, and today we're going to be talking about free fall. So, free fall is basically motion, motion due to gravity. So, with free fall, when we're talking about this motion due to gravity, we pretty much ignore air resistance and any other factor because we're just assuming that this is a perfect model in which gravity is the only influence moving that object. So it could be throwing a ball up and then that ball coming down. The motion of the ball coming down is all due to gravity, assuming that we're ignoring air resistance and some other factors. So when we're talking about free fall and gravity, we need to talk about acceleration because it is this acceleration of gravity that is a key contributing factor in allowing for our ball to pretty much go down, our ball to pretty much fall down as we throw it up. So some equations you have to know is obviously your big three, but you're going to exchange that acceleration that you had, the acceleration to x-axis, to the acceleration due to gravity. So the acceleration of gravity is simply shown as 9.8 meters per second squared. And when we manipulate our big three equations, all we're doing is changing the acceleration to acceleration of gravity. So our equations are going to look something like our velocity in the y-axis equals the initial velocity in the y-axis minus acceleration due to gravity times time. Our other one is position. So this is initial position plus velocity initial. And we're looking at the y-axis because when we're looking at free fall and we're looking at gravity, gravity is in a motion in the y-axis. You're not going to witness gravity going from the x-axis, going from left to right. You're going to witness it more or feel it more when you're going from top to down or down to up. So when we're talking about acceleration due to gravity and free fall specifically, we're just focusing on this one dimension plane. We'll get into motion in two-dimensional planes where we're going on the x and y axis, and it's sort of like throwing a ball horizontally, maybe just throwing a ball for catch or something like that, where we're going to the x-axis and y-axis. With free fall, we're just assuming if we drop a ball from a building or if we just throw it up from a straight position. So let me finish writing out our big three again, but just manipulating our equations. And over here, you guys remember the velocity over here. This is squared equals velocity initial squared plus 2. Now this is going to be times acceleration due to gravity. And then we have our positions. So these are the equations you have to know, and we talked about this in our past video on the big three and constant acceleration. So same thing goes, we still need constant acceleration, but we're using acceleration of gravity instead of just regular acceleration on the x-axis because we are on the y-axis. So now let's go through a practice problem to really illustrate how we can use these equations. Alright, so let's look at this question. So the question states that a ball is dropped from a leaning tower of Pisa and falls freely. Now ignoring air resistance, what is the position and velocity at 1 second, 2 seconds, and 3 seconds? So automatically we know that we're free fall because we see this word falls freely, and we're ignoring air resistance, so we can safely assume that the motion is mostly due to our acceleration due to gravity. So let's just actually draw this out to visualize what we're trying to find. So if we draw the Leaning Tower of Pisa, might look something like this. And we're trying to find the specific positions and velocities at 1 second, 2 seconds, and 3 seconds. So let's just say this is our starting point right here. And this is just pretty much going to be our plain y-axis because we're looking at the y-axis. So in 1 second, time 1 second, the ball might be somewhere over here. So t1 equals 1 second. Now our y1, which is just going to represent our position at time 1, is unknown, and our velocity as well is unknown. Now we get to 2 seconds over here, so t2 equals 2 seconds. Same story over here. We don't know our position, and we don't know our velocity. So maybe 3 seconds is over here, so t3 is going to equal 3 seconds. Same exact story. We don't know our position, and we don't know our velocity. Now, one thing we do know, though, is that this motion of the ball going down is going to be due to acceleration due to gravity. So I could put acceleration of gy or negative g, just negative gravity. And the reason why our gravity is negative is because we've determined that the point of origin is somewhere over here. So anything down to that would be negative, because anything above our point of origin would be positive. So you have to really understand where you're putting your positives and negatives, where you're putting your center of origin. And this also makes sense because if we're starting over here, anything below, if we're looking maybe at a chart, that would be negative, anything above would be positive. So that's one thing to note, is that you really have to understand at which direction you are putting your point of origin. So again, I have negative g over here, which is going to be negative 9.8 meters per second squared. And now that we know that, let's look at some of our equations to find out which one we can use to find position and velocity at a certain time. So one of the equations we can use automatically is that position equation. So that was position at a certain time equals initial position plus velocity initial plus 1/2 gt squared. That's gravity. So we know that our initial position is 0, so that's automatically 0. We don't know our initial velocity. And our initial velocity, we're going to safely assume that it is 0, because at time 0, that's when we're starting from the origin. So this is just going to be y equals 0 plus 0 plus 1/2 negative 9.8 t squared, which if you want to simplify, that equals negative 4.9 t squared. Now we could do the same exact thing for our other equation as well in order to find our velocity, because this is the equation we're going to be using to find our position, and the equation we'll be using to find our velocity will be our Vy equals velocity initial plus acceleration y-axis times time, or just gravity. You could also put g times t as your variables. It doesn't really matter what variables you use, as long as you understand and you know that this acceleration is going to be acceleration due to gravity. So our initial velocity is going to be 0, like we said. So this is 0 plus 9.8 t, and this is just going to equal 9.8 times time. So now all we have to do is just plug in our times and find our position and our velocity. Now I'm mostly going to skip the boring math stuff, because automatically you guys know how to put that in calculator, so I don't really have to go through just putting numbers in. So if you got your velocity 1 equals 9.8 meters per second, you'd be right, and your position would equal 4.9 meters. Now both of these would be in the negative direction. Now the reason why is because we have concluded that this point over here, when we're dropping the ball, that point where before we drop the ball, that is our point of origin. Anywhere below that, we're saying that that is negative. Anywhere above that, that's going to be positive. So now we could just do the same thing for our velocity and position at time 2 seconds and our velocity position at time 3 seconds. So our velocity at position at 2 seconds would be negative 19.6 meters per second, and our position as well would be negative 19.6 meters. Now our velocity 3 at 3 seconds would be negative 29.4 meters per second, and our position would be negative 44.1 meters. So one trend that you might have noticed is that as the ball gets closer to the ground, as the ball pretty much falls, our velocity is increasing in the negative direction. Now, it's because we're having acceleration, that acceleration due to gravity. Now, our acceleration is constant, which means that velocity is changing. And our velocity is changing to the negative direction until we pretty much hit the ground. So this is the biggest thing we were talking about in our motion time graph, where when we throw a ball up at the point where it's almost close to touching the sky or whatever, getting to its maximal point, it's going to stop a little, then it's going to accelerate down, speed down. The reason why is because our velocity and acceleration are in the same direction. Because our acceleration over here is negative, and our velocity is also negative, which means we're speeding up. So that's a little conceptual thing that you have to understand with free fall, is that when we throw a ball, it's going to first speed up, but then there's going to be a point where it starts slowing down when it gets to its maximal point. Then when it starts slowing down, it starts speeding up, avoiding that maximal point, like falling down for that maximum point, that maximum position, and it's going to speed up until it hits the ground. Alright, so now let's look at this problem. So the problem states that you throw a ball from a roof with an initial velocity of 15 meters per second upward, and it asks, what is the position and velocity at 1 and 4 seconds after leaving your hand? What is the max height the ball reaches, and at what time does it reach this height? And what is the velocity when the ball is 5 meters above the roof? So let's actually visualize what this looks like, so then we can actually solve this question. So one of the best things you can do in physics is trying to write out or trying to draw what the word problem is pretty much giving you. So let's just say that you're right here and you're throwing a ball upward at 15 meters per second. So let's just say your maximum height is somewhere over here and it dips down. So maybe something like this. Now we know our initial velocity equals 15 meters per second, but that's pretty much all we're given. So we can label some of these variables over here. And this position is something that we're trying to find. What is the max height? And we're also trying to find at what time we reach that maximum height. Now over here, we can represent this as T1 equals 1 second. So this is when the ball is thrown after 1 second. So we're trying to find the velocity of that. So we can do Vy1 equals unknown. Our Y0 is somewhere over here. So we can say that this is our initial position. And 4 seconds might be somewhere here. So T4 equals 4 seconds, and we want to find the velocity of this as well. We also want to find the position at time T1 and at time T4. So this is just kind of a visual representation of what we're trying to find. And also we can assume that the 5 meters above the roof might be somewhere over here. So not too tall. And we're also going above the roof. So we know that it might be somewhere over here. We don't know specifically because we don't know our total height. So we can safely assume that this is 5 meters. So we have all this information. And we also know that our acceleration or acceleration due to gravity is going to equal negative 9.8 meters per second squared. So I want you guys to pause this video and see if you can figure out what equation we can use to find our position and velocity at time 1 and 4 seconds. So to find our velocity, it's pretty simple when we use this equation over here. So this is plus gt. So this equation helps us understand what the velocity is at a certain time given our acceleration, which is due to gravity, and also our initial velocity. So this is just going to equal 15 meters per second plus negative 9.8, and this is times time. So for our first one, it's just going to be 1 second. So at time equals 1 second, our velocity equals 5.2 meters per second. So that is our velocity for time 1. Now how do we find our position? Well, we use our position equation, and this is one that you're just going to have to memorize. But once you do, you pretty much get it on lock. So we know that our initial position is 0, so we don't really have to worry about that. We know our initial velocity is 15 meters per second, and our time that we're looking at is 1 second, and this is plus 1/2 negative 9 or negative 9.8 meters per second squared, and this is times time 1 in seconds, so that's squared, and this is going to get us a position of 10.1 meters in the positive direction. So that's how you find your velocity and position given your time. Now remember, this equation is used towards finding our velocity, and this equation is used towards finding our position, given that we have a constant acceleration and we're given that acceleration, and we also have that initial velocity. Now for this one, it's just going to be the same story for time t equals 4, and I'll actually write down what those values are over here. So our velocity at time 4 seconds is negative 24.2 meters per second, and our position is negative 18.4 meters. Now the way we found that is we pretty much just replaced our 1 second with 4 seconds. Now the reason why I didn't write all the math down is because over here you could just replace the 1 with a 4, and that's how you find your answer. So now this was part A. Now let's look at part B, in which we're trying to find that max height. So I could just label this as B. So we want to find our maximum height. Now this is one conceptual thing you have to understand in physics, is that when we get to our maximum height, when the ball gets to the maximum height that it can, our velocity is going to equal 0. For that time being, our velocity is going to be 0 because our position is constant, because we're just maneuvering around a specific position, which is our maximum height. So if we know that our velocity is going to be 0, and we also don't know what time we reach that maximum height, we could go about this one of two ways. We could go about our equation where we're not given time to find our position, which is velocity squared equals initial velocity squared plus 2 times acceleration times our position y minus y0. We could go about that, or we could find the time and plug in using our position equation given time. So for this one, I'm going to use our equation that we're not given time, mainly because we haven't used it in this problem. So I just wanted to use that equation and give you guys some practice on using that equation. So that equation was velocity squared equals initial velocity plus 2 times acceleration. Now in our y-axis, our acceleration is going to be due to gravity since we're free falling. So this is going to be y minus y0, and our y0 is just going to be 0. So we could also just say that this is just y, because our initial position is just going to be 0. So this is our sort of variables. Now we know that our velocity is going to be 0. Our initial velocity is 15 meters per second, and we're going to be squaring that, and plus 2 times negative 9.8, and we have our position right there, which is our maximum height. So when you do the math there, you're going to get your position to equal 11.5 meters. Once you put all of that in a calculator, you're going to find that your position is 11.5 meters. Now this is the maximum height that we reach, and we have to know what time do we reach that height. Well, we can use our first equation out of the big three, which was velocity equals initial velocity plus acceleration in the y-axis times time, or just gravity. I'm pretty much using those variables interchangeably. So let me actually move our answers over here to solve this one. So this is going to be 15 meters per second, and this is going to be negative 9.8 meters per second squared. And we have time over here, and when we do that math as well, our time is going to equal 1.53 seconds. And if you wanted to double check your answer, you could use the second equation from the big three, which was y equals the initial position plus velocity initial plus 1/2 gravity times squared. So what we could do is we can leave our velocity variable just as it is, and we want to make sure we find 50 meters per second. So over here, this is 11.5 meters. Our y0 is just going to be 0, so this is going to be 1.53 velocity initial. So we're trying to find our velocity initial just to double check that if this number is 15 meters per second, then we know that our maximum height is indeed 11.5 meters, and our time at that maximum height is 1.53 seconds. This is 1/2 negative 9.2 meters per second squared, and this is going to be 1.53 squared. And let's do that math real quick. So over here on the left side, we're going to get negative 11.47, and this is going to be 1.53. Velocity, this is going to equal 11.5 as well. And over here, we just have to move our negative 11.47. So that's going to be 11.5 plus 11.47. That gets us 22.97 equals 1.53 velocity initial. And when we do that math as well, we get 15.01 meters per second, or pretty much we just get 15 meters per second. So one thing you could do when you're going through your physics questions or even your exam is make sure you double check your answers, because whatever you get for this maximum height, whatever you get for this time, it should be used interchangeably so that you pretty much get the same answers if you're, for example, trying to find the initial velocity, which you can double check and you can safely assume that those are your correct answers. So now we have one more question, which is question C. And question C was stating that what is our velocity when we are 5 meters above the point of origin? So for this question, we know that our initial velocity, and I'm just going to write this down, our initial velocity is 15 meters per second. Our acceleration due to gravity is negative 9.8 meters per second. And our position that we're looking at is going to be 5 meters. Now the thing is, we don't know the time at which we reach this 5 meters. So we need to use our equation of velocity squared equals initial velocity squared plus 2 times gravity. And this is going to be y minus y0. And if we plug in our numbers, we are trying to find our velocity at that certain position. So we're going to plug in 15 meters per second, and this is going to be squared plus 2 times 9, negative 9.8 meters per second squared. And this is going to be 5 minus 0. We could also just put 5. And we could also say that this is square rooted. So this is going to be our velocity. The reason why I just put square root is because to get rid of this square, we square root. So if we go through that math real quick, we're going to get a plus and minus 11.3 meters per second. I'm just rounding this number up, but when you put it in the calculator, you're going to get a plus or minus 11.3 meters per second. Now, the reason why we have a positive and a negative velocity over here, so I'm going to make this Vy equals that, is because if we look back to our drawing over here at 5 meters right here, we touch that point twice. So we're hitting that point of our route, you could say, where our velocity over here is going to be positive 11.3 meters per second, but then when we're coming down, it's going to be negative 11.3 meters per second. So that's why we're having this plus and minus, we're having a positive and a negative velocity with the same value. So that pretty much concludes our discussion on free fall. Now hopefully this practice really helps you guys understand how free fall problems work, and all you have to do is just use your big 3 equations. So memorize those, and as always, a Pomodoro day will make you a doctor someday. I'll see you guys in the next one.